In the previous session, two methods of stepper motor motion were explained. The first method, which we called instantaneous, applied a fixed frequency pulse rate to the translator, which moved the motor shaft at a constant speed. The ability of the motor to accelerate to speed within the boundary of the first and second step position limited the instantaneous speed that the motor could attain using this method. However, once a motor begins moving instantaneously, higher shaft speeds could be attained by gradually increasing the pulse rate. We called this the accelerated method. This session will explain how instantaneous and accelerated motion applies to accurate positioning and position tracking. Indexer LPT keeps track of the control pulses that it generates, adding positive and subtracting negative movements. It is necessary, however, to initialize the starting position for pulse tracking to have meaning. The initial, or zero position, is called the home position, which is set by Indexer LPT's set home command. Before position tracking is initialized, Indexer LPT will execute motion commands, but it will not report its position. Here 1,000 pulses are generated using Indexer LPT's move command, but the destination position is reported to be unknown. Now, after initializing position tracking, the move command is used to generate 1,000 pulses, and the destination location is reported. After generating 600 pulses in the negative direction, the location is 400 steps from the home position, reported as shown. In this example, the G-code controller application program directs Indexer LPT to automatically determine the home position. From an unknown position, it initiates an instantaneous movement lengthy enough to always be interrupted by an end limit switch. Indexer LPT reads the limit switch before sending each pulse, so the motor is stopped instantly when the limit switch is contacted. Instantaneous motion is used to accurately stop on the pulse that causes the switch to be activated. Accelerated motion is used to rapidly withdraw the stage from the switch to a position that will be referenced as home. Here is a way external switches are used to initiate machine motion. Indexer LPT does not require switching an externally applied oscillator to the translator for manual controls. Instead, Indexer LPT senses the status of the joystick switches and keeps track of each pulse that it generates. With the fast option selected, the joystick accelerates the motor for rapid positioning. Some overshoot may occur during deceleration when the switch is released. The slow option, however, uses instantaneous rate, so that the motor stops the instant the joystick switch is released. The operator can still vary the instantaneous rate with the feed rate override dial, as shown here. The robust joystick response of instantaneously starting and stopping greatly increases ease of use. A separate session will be devoted to Indexer LPT's joystick option, as well as the feed rate override feature. The point that is emphasized here is to demonstrate controlled stopping and position tracking. Later, we'll see how it enables G-code controller to accomplish things like locating fixture offsets, sensing a homing plate, measuring and assigning values for tool length compensation, and recovering from tool breakage. So far, we've only discussed controlled stopping. Uncontrolled stopping occurs when an end limit switch abruptly interrupts any movement that requires acceleration. If acceleration is required, position information is not considered reliable if the motion is abruptly terminated. In such cases, Indexer LPT abandons position tracking on all affected motors until the home position is re-established. Indexer LPT's feed-hold feature was designed to provide for controlled stopping whether or not accelerated motion is being employed. Activating the feed-hold switch will bring all motion to a decelerated and controlled stop. Position tracking is preserved. Deactivating the switch accelerates the motion into its resuming path. When motion is stopped, however, activating the release switch provides the application program with the opportunity to exercise additional control, such as G-code controller's option to recover from broken tools, change offsets, and to resume from a prior location along the tool path. A separate session will be devoted to recovery from interrupted operations. But now that we've covered the implications of instantaneous and accelerated motion, and controlled and uncontrolled stopping, it's time to explore multiple motor control in our next session, entitled Interpolation.